I'm Gaurakrishna, and I will start from where I left off from the previous class. So we were talking on the chapter, the language of chemistry, ICSE class 9, chapter 1. Okay, so in these pandemic times, we would study these chapters online, and here we have started. So the first, here we were talking about all the formulas and we have talked about all the important formulas. Okay, so our next topic is chemical equation. Now what is chemical equation? So everyone defines in their ways. So I define a chemical equation as it's a chemical equation, so chemically made. And so we cannot, if it is the equation is chemically made, then we cannot reverse it, it is irreversible. So in shorthand, we can say that the chemical equation is in simply was the result of what the reactants and the products, and there are many laws over it. In simply we can say they should be equal, like the products mass and the reactants mass should be equal. Okay, so in simply words we can say this. And then we have balancing of the equation. Balancing is very easy in terms in here. Well, balancing is what we have to just balance their mass and valency. Okay, so now in this balancing we will talk about the left hand side and the right hand side. Left hand side is the reactants that you would react, and the right hand side will be the products, which would what would be the products. And in between there would be this in between there would be many formulas, and in between there would be an arrow, like in the presence of heat, in presence of sunlight, and like that in between. Okay, so starting with this we come to this chapter. Okay, so we were talking about if I am giving you an example, there are like examples like plaster of Paris and many more, gypsum. Okay, so these were some high level these are some high level questions that I would give you. But first simply comes to understand, you would take a simple example. Okay, as you can see, 2 pb. Okay, as I am writing here, one reactant and two or three products. If there is only one reactant, then means that it is endothermic. Endothermic meaning heat is, we need heat. In the presence of heat, this reaction would be possible or it would not be possible. And in exothermic, the products, one of the products would be heat. Okay, if heat is being released, then it would be exothermic, and if heat is taken, then it is endothermic. Okay, so here we are talking about these chemical equations, and as you can see the equation above here, and here as we are able to see, these are some reactants. Here if you would see that 2 pb and 2 pb both are equal, so they are valentically balanced. What does balance means? If there are 2 lead molecules, Pb is lead. Okay, so 2 lead molecules in their product reactants, then there should be 2 lead products in products. That is product and reactants. Nothing to do. We have to just balance it. Means the number of oxygen atoms, number of nitrogen atoms, number of lead atoms should be equal in the products and reactants. That is everything. And we can understand there is no law. Law of mass says that if it is 44 gram in the reactants, then it will be 44 gram in the products too. Nothing else in that. Okay, so this was there was a law of mass, then law of conservation of energy. The energy cannot be lost by that atom. It will be just transferred from one atom to another atom. Okay, so these were some things. Now we have to study the limitations. Now what are these limitations? Limitations are, if we have done this reaction, we cannot perform like this is the same reaction from this. From products we cannot go to the reactants. It is like function. What is function? Here if we are going from this to this, it's F. But if we are coming reversely, it's F inverse. But here we cannot do the same. So we cannot do the same. It's irreversible, as just studied in earlier classes also. Now, as I talked about balancing of equation, everything should be balanced. And here are some examples also. We should balance equations. Balance equations means if one side is heavy, other side is very light, then it would be not balanced. In a tug of war, if both sides are not equal, then it is not balanced. If you are making the strong players at one side and the that weak players in one side, then the weak players side would lose. That is not good, and that's not that called that is not good, and therefore we should balance it. It should not be unbalanced, or the time would lose. Okay, and we should not be partial with the heavy ones. So as we study the so now there are many. First is the hit and trial method. Hit and trial method says that you should first take the lead molecules. If the lead molecules are equal, then second, and check for every and make each molecule equal step by step. Then at last you would get all molecules equal automatically. As I am giving you an example. Okay, if you take an example, I am in simple, is that if you in simple words, if I am given H2O, okay, H2O, what is this? It's not a chemical equation. It's a chemical expression. Expression and equation, what is the difference? There should be an equal to sign also in an equation. Okay, and H2O does not has any equal to sign, and therefore it is a chemical expression, not a chemical equation. Okay, so as we were going through H2O, so as we asked about the H2O, that is wrong. Okay, so the next example, any example if we can take, the one example that comes in my mind is that gypsum. It's gypsum, that is in difference between a plaster of Paris and gypsum is only half H2O. Half H2O is the difference between this gypsum and Paris. I am saying the total formula is 2KMP 1 by 2H2, and here it is 2KMP but 2H2. Okay, so what we see in the simpler words I am saying, I see that the number of hydrogen molecules in the products is more than the number of hydrogen molecules in the reactants. Then the students ask that how is it possible? Is this reaction wrong? Then the answer to it is not balanced. And if we were balanced it, then it would be equation will be correct. Okay. So comes some oxidation and reduction reactions. Oxidation is when we add oxygen molecule or we remove hydrogen molecule. Or reduction is when we remove hydrogen molecule or we add hydrogen molecule. This is only oxidation and reduction reactions. Okay, so these are simpler things. Now, as here are many questions, I would take a simple all the questions step by step. Okay. So state why the compound MnO2 is written above the arrow. Okay, so you here in question number 14, as we are able to see, okay, part A, state whether and what is balanced equation. So as you know, balanced equation when the mass and the energy of products and reactants are equal. Give a reason why the above equation is balanced. The above equation is balanced because every atom has equal number of atoms in the products and reactants. Okay, so these were the answers of part A and part B. Part C, state why the compound MnO2 is written above the arrow. Okay, so MnO2 is a gas, and therefore in the presence of MnO2, 2KClO3 would react to 2KCl3O plus 3O2. 3O2 is oxygen. Okay, and now 15. Okay, I have skipped some questions, I think. Okay, so yes, so as you were talking, write the formula from the following compounds. So potassium, we know potassium chloride, potassium nitrate, and it is very simple. We can say potassium or just add potassium chloride, nitrate, carbonate, bisulfate, and like this continued. Same with sodium chloride, magnesium chloride, magnesium bicarbonate, sodium like this. This question is done like silver, and I would like to tell you something. Platinum, gold, silver, mercury, copper, all these are very less reactives, and they like water. Steam is the most reactive substance, and these metals like gold, copper, mercury, silver, platinum don't react with water. Steam of water is highly reactive, And like if you would react this steam of water with potassium, it would be a huge blast, because potassium and sodium are like they are also mostly reactive, and this is also reactive, so there's a huge blast. Okay, so we write the names. We can name it potassium chloride and hydrogen chloride, and these, and we can name it. Now explain the term chemical equation. What is the term chemical equation? To explain chemical equation, we can simply define chemical equation as an equation where there are two terms, products and reactants, which have equal mass and equal energy. Okay, that's the chemical equation. What is meant by reactants and products as I defined here? Reactants are the left hand side, and products are the right hand side. And this is only the reactants and products. Okay, so give an example of a chemical equation in which two reactants form one product. So there are many, like one product formed water. If you are reacting hydrogen and oxygen, you would form water. Okay, so two products we can give many examples. The one of the examples that I come to here, like here only you can see potassium chloride, aluminium chloride, and many more. Okay, from one we can form two, aluminium and chloride to form aluminium chloride, two products. Three products. Okay, the same thing, H2CO3. The example here given, it's hydrogen. It's the formula is hydrogen bicarbonate. What is that? It is here hydrogen, carbon, oxygen. Three. So three products. And four we can take magnesium hydrogen carbonate, that is MgHOCO3 too. Okay, so like this we can form many. I have given you one example, there can be many examples given. So 2KLCO3 as the word suggests. Okay, I have done question number 14. What do the symbols? So this arrow means that from reactants to product, the first one. The second one means that we are equaling that equation. This equation is balanced, and SLVGA, S is solid, liquid is L is liquid, G is gas, and AQ is aqueous, meaning it is also liquid present in the chemical equation mean, as I have said. Okay, so see here is one more equation. State the information provided by the above chemical equation. Now here it says that calcium chloride plus 2HCl. HCl is what is 2HCl? Cl is an acid, and if we are and what we call it as okay, so it is forming CaClO2 plus H2O. H2O is water and CO2 is carbon dioxide, and CaCl2 is your calcium bicarbonate. Okay, so we are moving next. So balance the following simple equations. Okay, so I am balancing it here, and if we are seeing C plus O2 is CO. So if you would write 2C plus O2 is equals to 2CO, then it would be balanced. 2 carbon atoms and 2 oxygen atoms. And N2 plus O2 is NO. If we would write 2 equal to 2 NO, then it would be balanced. Okay, so ZNS plus O2 is ZNO. Okay, so to balance this, plus ZNO plus SO2. So here in as we are able to see the Zn, zinc atoms are equal, so S atoms are also equal, and oxygen atoms, they are 2 in the products, reactants, and 3 in the products. Okay, so 2 and 3 we should multiply 2 with 3 and 2 with 3 and 3 with 2, then it will be 6 equal to 6. Okay, so like this we would balance all these equations. And now we have done potassium nitrate plus oxygen, and we have balanced all these equations. And now our next topic is, now we are now studying in the high formula of balancing. Balancing, like here we were doing only from 1 to atoms, and if there would be many products, like here it is 5 in the first part, it is 5 formulas. So to balance these we can make a chart meaning that we can first make a chart like this and write Na sodium, Na. Okay, Na, and then NaHCO3. What is NaHCO3? It is sodium hydrogen carbonate. Okay, so sodium hydrogen carbonate. Okay, so that is NaHCO3. H2CSO4 is hydrogen sulfate. And so you write that if for sodium atoms in the products, sodium atoms, products and reactants. For products, for for the reactants, the sodium atom is 1. For the product, the sodium atom is 1.